The problem is from GATE 2019 mathematics paper, question number 3. The problem given is, let f from C to C, the set of all complex numbers, be defined by f of x plus iy equal to x cube plus 3xy square plus I times y cube plus 3x square y, where I is square root of minus 1. Let f dash of z denote the derivative of f with respect to z. Then which of the following statements is true? Since it is asked is true, we can say there should be only one correct answer. So the four options given are option A, f dash of 1 plus I exist, and f dash of modulus of f dash of 1 plus I equal to 3 square root 5. And option B, f is analytic at the origin. Option C, f is not analytic, f is not differentiable at I. Whereas option D, f is differentiable at 1. So the NPTEL reference to solve this problem is Module 2, lecture number 3 of complex analysis. The title of this lecture is Differentiation by Dr. P.A.S. Sri Krishna. He is from Department of Mathematics, IIT Guwahati. Even you can watch this lecture using this YouTube link. So now coming to the solution. We have the function f of f is given as from C to C, and it is given as f of x plus iy defined as x cube plus 3x square y, x cube plus 3xy square, xy square or x square y, xy square plus I times y cube plus 3x square y, where I is square root of minus 1. So now looking at the options, we can see it is asked to check whether f is differentiable or not at the points I, 1 and 1 plus I. And of course, the option B is about analyticity. So by looking at the options, coming to the solution, we can write the function f of x plus iy as u of x comma y plus I times v of x comma y, where u of x comma y is real part of f of z and v of x comma y equal to imaginary part of f of z. So now for the given function, we have u of x comma y is x cube plus 3xy square, and v of x comma y is y cube plus 3x square y. So now coming to the options, since it is asked to check the differentiability of this function f of z, and we know by the definition of differentiability, we say a function f of z as u plus iv is differentiable at a point, let me say at z naught, if ux, uy, vx, vy have partial derivatives and u comma v satisfy Cauchy-Riemann equations, that is CR equations at the point z naught, then we can say the function f of z is differentiable at z naught. So since it is given, we already have u and v for the given function. We will check whether ux, uy and vx, vy have partial derivatives, and if does those two functions satisfies Cauchy-Riemann equations or not. So we have, since we have u of x comma y equal to x cube plus 3x square y 3xy square v of x comma y equal to y cube plus 3x square y. Okay, so from this we have ux equal to 3x square plus 3y square and uy equal to 6xy. Whereas coming to the v, we have vx equal to 6xy and vy equal to 3y square plus 3x square. So now we check with, and from this we can easily see the partial derivatives ux, uy, vx and vy. How continuous are continuous. So ux, uy and vx, vy are continuous since all these four functions are polynomials only. These four functions. So here ux, uy, vx, vy are continuous. One can write are continuous, or one can write u and v have continuous partial derivative. That is entirely this line. Ux, uy, vx, vy are continuous. So from this we have, and these are continuous. But another condition it has to satisfy is the Cauchy-Riemann equations. That is ux has to be equal to vy, and from this you can see ux equal to vy. But we have uy is equal to 6xy. That is not equal to minus 6xy. That is as minus vx. Or let me write in this way. But uy is not equal to minus vx, since these two are the Cauchy-Riemann equations. But here we have ux equal to vy in all the cases. But coming to the point, uy equal to minus vx, it happens for xy not equal to 0. And we have ux equal to vy and uy equal to vx minus vx for xy equal to 0. That is, we have the Cauchy-Riemann equation satisfied for the cases whenever xy equal to 0. That means whenever we take this as complex plane, we have the curve xy equal to 0. That is nothing but either x-axis or y-axis. Then only we have the condition xy equal to 0 satisfied. So from this we can see the Cauchy-Riemann equations will get satisfied for the complex numbers z equal to x plus iy whenever the complex number is lying on either x-axis or on y-axis. That is, so u comma v satisfies the Cauchy-Riemann equations only on x and y axis. So that is nothing but, so f is differentiable only on x and y axis. So now from the given options we can say f dash of the first option, f dash of 1 plus I exist, since it is the point 1 plus I does not lie either on x-axis nor on y-axis. So we can say f dash does not exist. And since whenever it does not exist, we don't need to talk about that its absolute value. And option B, f is analytic. That means it has to satisfy, it has to, whenever f is analytic, it has to have continuous derivative. But whereas coming to the derivative case, since f is not derivable first of all, so we can say f is not analytic. Coming to the option C, f is not differentiable at the point I. Since the point I lies on y-axis, we can say f is differentiable from the condition we derived. So we can say f is differentiable at I, but the option given is f is not differentiable at I. So we can say option C is incorrect. Coming to the option D, f is differentiable at 1. Since 1 is a real number and which lies on the x-axis, so we can say f is differentiable at I by the condition we have derived this condition. So we can say, so f is differentiable at 1 but not differentiable at I. So we can say option D is correct.